So here is our bell work. What the diagram above, shown above, best represents which of the following? Yes. Law of conservation of mass. What goes in must come out. Sorry. Law of conservation of mass. And then the next one is a 10-gram piece of metal is submerged in a graduated cylinder, initially containing 20 milliliters of water. With the metal in the cylinder, the level of the water is recorded at 21.40 milliliters. Determine the identity of the metal. So, what is it? How would we solve it? How do we find density? Density is mass divided by volume. We know the mass is 10. We got the volume by displacement, which is 21.40 minus 20, so 1.4. So the answer is B, zinc. Any questions over that? How to find volume using displacement. Okay. So let's take a look at law of multiple proportions. What this does is it just takes our numbers, and we're looking at the grams, and we go and we take our small whole number ratios, or we take it to a proportion. So we get small whole number ratios or proportion. So this is kind of like empirical formulas. So what we see here is we have this data of nitrogen and oxygen. We have nitrogen, the mass of nitrogen that is combined with 1 gram of oxygen. So each one of these nitrogens or compounds has nitrogen, and it's combined with 1 gram of oxygen. So if we have compound A, compound B, and compound C, what we want to do is we want to get these numbers right here into whole numbers. So what we're going to do is we're just going to look at each one, and we're going to divide it by the smallest number. So A is 1.750, B is 0.8750, and C is 0.4375. What we want to do is we just want to divide each one by our smallest, like we do in empirical. And we get this down into a whole number. So this is 4, this should be 2, and this should be 1. Okay, so it's a 4, 2, 1. Which means that there's 4 times as many nitrogens in A as there is in C, and there's 2 times as many nitrogens in B as there is in C. Or mass. You can do it with the mass. So is there any questions over how to do that? The AP exam wants you to know how to do it. They've never tested over it, but they do want you to know how to do it, and you will see that on your quiz too. There are 7 free response, 3 long, which should take you 25 to 30 minutes, and 4 short, which are about 15 minutes. The 3 long are 10 points apiece, and the 4 short are 4 points apiece. Okay. Again, this is how to look at it as numbers. It's just a play of your proportions. And you see that for every 2 N's we have 1 O, or for every 1 N we have 2 O's. And this is just what we came up with a while ago, right? 4, 2, 1, 1. But it's just written, this would be our 4, this would be our 1, and this is 4 times this one over here. So when you're looking at these all just ends. This is a 2, this is a 1, and this is going to be, what is that? 1/2. So it's just going around, it's just showing it as a different way. But you see that there's a definite proportion going on. It's always 4, 2, 1, 1, or 4, 2, 1. And you'll have something like this on your homework. I think number 3 is kind of like it on your homework. Any questions on that one? All right, let's get to the periodic table. All right, periodic table. We have hydrogen is right here, and hydrogen is over here because it has a +1 charge, but sometimes you may see hydrogen over here, okay? And that would be because it's a non-metal. You can see it either way, but remember, it's not a halogen, it's by itself. Alkali metals are your first column. Alkali earth is your second column. You have your transitions, which are right here. And then we have our halogens and your noble gases in the last column. And these right here are called what? The rare earth or the inner transition. Either one. Inner. I-N-N-E-R. These guys here on the stair step are called what? Metalloids. So you need to know your names of your groups and your families. And then, what else do we know about the periodic table? We know that these numbers right here, the upper right-hand corner, represent what? The atomic number. And atomic number will also be seen as a Z. Okay? And the atomic number represents what? The number of protons. If you change your number of protons, what happens? You change your element. Any question? Huh? I'm not going to be, I mean, aluminum is not a metalloid, so it's kind of, I would just know that there's that little transition state right there, but you're not going to be tested on is that a metalloid, or is it more metal, or is it more non-metal, okay? Do you need to know what? The poor metals? No, I mean, I would know that they're metals, but any other questions? I will be coming back to this table. Yes. Halogens is your group 17. And then your noble gases is the last column. Okay. So let's talk about the next thing. It says, I'm going down to number 10 because I'm kind of out of order here. The charges of common univalent cations and anions. So what we're going to do, and it says charges of multivalent cations. What we're going to do is we're going to go back to the periodic table. So we're going to put on here, let me change my color. C, periodic table. So let's go back up here to the periodic table. No. Let's see here. The first column is what? Charge. +1. Column 2 is +2. Over here, our halogens we know are -1. O and S, those are -2. N and P are -3. And we know that aluminum is a +3. So those are about the big ones. And we know that the noble gases are 0. While these down here, these noble gases do form bonds, they're not ionic bonds. So we'll talk about those later. But just know those are our single valent ones, okay? Now, there are some transition ones that are single valent, and what are those? Which ones do not always have the same charge? Silver is always a +1. Alright, if you look at my periodic table over here that is hanging on the wall, you see that silver is under column 11. I always hide the first number, and that tells me it's a +1. Whereas zinc and cadmium are in column 12, I'm going to hide the number 1, and those two are always going to be +2. We're going to talk about that. And then we know that aluminum has a +3. Okay, so if you see the stair step, that aluminum, we know aluminum is always +3. And then you see the stair step, aluminum, zinc, silver. 3, 2, 1. And then since cadmium's under zinc, we're going to make it a +2. Okay? Now we are also going to memorize and know the following. Iron, cobalt, and nickel. Those three right there will do +2 or +3. Iron, cobalt, nickel will be +2 or +3. Gold, down here, Au, can do +1, +3. And then lastly, these four right here, tin and lead, and then antimony and bismuth. Tin and lead do 2, 4. And antimony and bismuth do 3, 5. Yes. And the last one I forgot to put in here, copper is a +1, +2. Okay, so iron, cobalt, nickel, +2, +3. Gold, +1, +3. Copper, 1 or 2. And then tin and lead are 2, 4. And antimony and bismuth, 3, 5. So just kind of think of these kind of a little pattern right here. You're always going to be given a periodic table. So just kind of get used to find a pattern in there, like the aluminum, zinc, silver pattern.
So is the tin can be 2 or 4? Is that one's 2 and then the next one's 4? They can be either or?
Tin can be 2 or 4, okay. And lead can be 2 or 4. So And then the bismuth and antimony can be 3 or 5. Yes. Yes, fill the pass out. Make sure your ID's on. Any questions on the periodic table? The number at the bottom of here on the periodic table represents what? I don't have it on here, but if you look at my periodic table, what does that number at the bottom represent? The mass, but what type of mass? I know atomic mass, but what type of atomic mass? The average atomic mass. That's why it is in decimals. Okay, so average atomic mass. It's the mass of all the isotopes that can be found. Everybody good? All right. All right, so here is a condensed formula. We want to identify, we want to identify the numbers of protons, electrons, and neutrons. So protons, neutrons, and electrons. The number at the bottom, so if we were to say this is element X, the number at the bottom, which is Z, represents our number of protons. So Z is the number of protons. And the number at the top, A, is our mass. So in silver 109, how many protons does it have? 47. How many neutrons does it have? 62. How many electrons does it have? 47. Magnesium 24. How many protons? 12. How many neutrons? 12. How many electrons? 12. What about for aluminum? 13, 11, 13. And what about silver 107? 47, 60, and 46. What if we had sulfur 32 with a -2 charge? How many protons does it have? 16. How many neutrons? 16. And how many electrons? 18. Yes. Not silver. So I said sulfur, didn't I? Or did I say silver? Sulfur, sorry. Any questions on that? All right, let's do some naming. What is the name of NaCl? Sodium chloride. What about CaBr2? Calcium bromide. If you have a question, please speak up. K2S. Potassium sulfide. Cu3N2. Copper 2 nitride. Where'd the 2 come from? Because of the charge. We have to balance the charges, right? And it is, copper is in the transition metal, so we have to put the Roman numerals in there. What about AlF3? Aluminum fluoride. Ag2Se? Silver selenide. COI3. Is cobalt transition or no? Yes. So what's the charge? 3. So it's going to be cobalt 3 iodide. We know that I is -1 and there are 3 of them. So cobalt, with there being 1 of them, cobalt has to be a +3. And the last one. Ooh, what's the charge of sulfide? Sulfur. Sulfur is a -2, and there are 2 of them. So that is a total of -4. So tin has to have what charge? 4. So it is 10, 4 sulfide. Any questions on that? All right, let's go to writing the formulas. Calcium is Ca, and calcium has a +2 charge. Sulfur is a S, and it has a -2 charge, so the formula is just CaS. So I'm going to give you a few minutes. I'm going to pause this and give you guys a few minutes to work those, and then we'll come back and share them out. All right, barium fluoride. What is the formula? What'd you say? BAF2. Sorry, I'm half deaf. BAF2. And cesium hydride? Oh, CS. CSH. Lithium phosphide. Li3P. Copper 1 oxide. Cu2O. Bismuth sulfide. Nickel 3 bromide. And cadmium nitride. CD3N2. Cadmium's always a +2. Questions over that? All right, so let's go to the next ones. All right, so these are what type of bonds? Covalent. So we are going to use the words mono, di, tri, tetra, penta, hepta, or is it hexa? Hexa, then hepta? Hexa, hepta, octo, nona, and deca. Huh?
What's 5 again?
Penta.
Oh,
So NO would be what? Remember, we only use mono on the second one and if it's oxygen. So NO would be nitrogen monoxide. NO2 would be nitrogen dioxide. So take a few minutes and do those real quick, and then we'll come back. N2O4. Dinitrogen tetroxide. P3N5. Triphosphorus. Pentanitride. SO3. Sulfur trioxide. P4O10. Tetraphosphorus decoxide. NF3 nitrogen trifluoride. And CCl4 is carbon tetrachloride. Alright, so here we just have real quick a mix of stuff. So, silicone dioxide, what's the formula? SiO2. Barium fluoride would be BAF2, since it's ionic. Boron trichloride would be BCl3. Lithium phosphide would be Li3P. Xenon tetrafluoride, XeF4. Tellurium tetraiodide, TeI4. Phosphorus pentabromide, and sulfur dichloride, SCl2. And that will finish up today's lecture. Tomorrow, quiz, and then we will get into ternary nomenclature, which is just with our polyatomic ions that you guys should be memorizing.